Transforming the School of CRETE into intelligent, nearly zero energy building, from the collaboration of municipality of ΗΡΑΚΛΕΙΟΥ with the University of Cyprus and the Regional Development Fund of CRETE. And the presenter will be ΖΑΧΑΡΕΝΙΑ ΔΡΟΣΟΥ. ΖΑΧΑΡΕΝΙA, the floor is yours. Thank you very much.
Thank you, Mr. Konsolakis. Good morning, everyone. Before I begin my presentation, I would like to congratulate the organizers of the 4th Symposium on Circular Economy and Sustainability. Today I'm here as project manager in the European project named CIZEBS, which focuses on transforming a school of Crete into an intelligent, nearly zero energy building. The project is co-funded by the European Union, ERDF, and national funds of Greece and Cyprus through the INTERREG 5A Greece-Cyprus 2014-2020 cooperation program in the access, efficient use of energy and sustainable transport. The European Union, through the Energy Performance of Buildings Directive and the Energy Efficiency Directive, has been establishing requirements and expectations regarding energy savings and efficiency in buildings. Educational buildings comprise a significant part of public buildings that should lead the way in the energy retrofitting of existing building stock. The present project aims to create an intelligent school complex that will be energy upgraded to meet the need for reduced energy consumption in the public sector in order to comply with EU guidelines, optimize the sense of comfort, introduce the renewable energy and enhance sustainability mobility by creating electric charging stations for vehicles. Retrofitting approaches consider thermal insulation of the building envelope, replacement of heating and lighting system, and more efficient ones, and installation of building management system for the creation of an electronic application that will monitor the energy status of the building in real time and will train users in the proper use of new energy management technologies from renewable energy sources. The overall objective of the project is to create an intelligent building standard of nearly zero consumption, which promotes an overall ecological character of public buildings, demonstrating their social role. In my presentation, you will see the objectives, the methodology, retrofit solutions, expected outcomes, and conclusions. Identifying solutions for reducing energy consumption is a key element for fostering energy security, climate change mitigation, and transition to new energy sources, which in turn reduce the global environmental impacts. EU directives require countries to develop long-term renovation strategies aiming to facilitate the cost-effective transformation of existing buildings into nearly zero energy buildings. Energy efficiency is a key element in sustainable buildings. The research was conducted under the INTERREG 5A program, like I told you previously, and the retrofitting measures of a public educational building in Crete, and specifically the high school of Agios Myronas, so as to be used as archetype project for energy saving in public buildings. And the integration, of course, of an electric vehicle charging station and supply of an electric bus. The focus here is on energy upgrade and electromobility integration, highlighting energy saving and ecological sensitivity at the high school of Agios Myronas. According to the Greek Energy Performance of Buildings Directive, EPBD, Agios Myronas, a village in the municipality of Ηράκλειο, Crete, belongs to the climate zone A, which is the hottest among the climate 4 zones ATD in Greece. The lowest minimum air temperature is 5.5 degrees based on studies recordings in March 2022, and the highest mean maximum air temperature is 30.6 degrees based on recordings taken in August 2022. The concerned building is the one situated, as you see here in the picture, at the west part of the building complex. The pilot building is a 2-floor building, 1,300 square meters, out of which 23 square meters is considered a non-conditioned space, which stands for washroom, storeroom, and central heating system room. The building is thermally unprotected. The thermal insulation of the piping network is inadequate. The lighting system consists of fluorescent lights. The oil burner is conventional with the radiators as regional units, and the cooling system is with a split unit. Concerning transportation requirements, Agios Myronas hosts major public services which serve citizens from at least 6 surrounding communities of about 5,143 inhabitants, according to the 2011 census, which reflects increased needs for public transportation means of adequate capacity and frequency. The main route interconnecting the communities extends to approximately 40 kilometers, while in the General University Hospital of Ηράκλειο is added in the main route. If this is added in the main route, then the distance is about 50 kilometers. To assess the energy performance of the building, a thorough energy audit was performed, including energy rating using the National EPBD, software technical instructions of the Technical Chamber of Greece, KENAK, which employs the quasi-study of monthly time step calculation procedure according to the ISO 13790. The building parameters were used as input conditions towards the calculation of energy consumption, and a twin building which meets the minimum energy performance requirements as per the Greek EPBD was used as a reference building to calculate the divergence and see the simulation results. Here we see the key performance indicators of the pilot building in the existing situation revealed here at this table. And we see that the heating purpose covers the largest energy share. If we do the calculation, that entails a 49.21%. Additionally, an energy share of 37.11% and 13.66% is allocated in lighting and cooling, respectively. In comparison to the twin reference building, the actual building is total primary energy consumption is about 41.2% higher than the former, admitting that a relatively high energy saving potential is possible. The interventions done in the building fabric was in the roof, which is graphite expanded polystyrene was used for insulation, and bearing structure and brick wall, also graphite EPS slabs, was used for insulation. On the roof we see a thermal transmittance of U value 0.387, and the brick wall of the achievable thermal transmittance was of U value 0.369. Energy interventions were also done in the windows, artificial lighting and heating system. In the windows, they were replaced by double glazed and laminated windows with aluminum frame with 18 millimeter air gap with low membrane at the external glazing. The new thermal transmittance of the windows is U value 2.192. And according to the study, the lighting was replaced by existing fluorescent lamps with LED ones. That will ensure lighting level of 30 lux required by the PPD directive for school buildings. As far as the heating system goes, the conventional oil burner is replaced by a condensing oil burner with integrated weather compensation system with usage power of 150 kilowatt at operating temperatures, 80 degrees and 60 degrees respectively, and efficiency of 96.4%. Using the photovoltaic geographical information system, which is an online tool and based on the total expected electricity consumption and the geographical location of the pilot site, a PV system of 19.68 kWp is derived as the best one to cover the concerned points of delivery under the mechanism of virtual energy sharing. However, according to the ongoing legislation, currently the license for a PV system is limited to a maximum power of 10 kWp due to limitations regarding grid available margins for RES technologies. So the PV system here in the school building is eventually prescribed to a 10 kWp to ensure prompt licensing procedures and fast electrification. There was also an implementation of a building management system based on CANEX protocol. The system will be used only for monitoring purposes, the measurement of thermal energy in kilowatt hours of the heating system, and monitoring of the indoor thermal comfort conditions through internal air temperature and relative humidity sensors. This was installed before the implementation of energy interventions in order to ensure measurements before and after the renovation works towards the assessment of energy savings due to the interventions applied. Hourly measurements and storage are ensured in order to understand the dynamic energy and thermal comfort performance of the building before and after retrofitting. There's an integration of an electric minibus dedicated to cover local transportation needs of students and citizens. This bus has autonomy of 280 kilometers per full charging, a total capacity of internal battery 65 kilowatt hours. The maximum final velocity of the bus is 80 kilometers per hour. And the vehicle charging needs are of 2 AC chargers of 22 kilowatt. Capacity of simultaneous charging of 2 vehicles is possible. And installation at the municipal property is also efficient in the village of Agios Myronas near the high school. The starting ending point of each bus route will be the position of the charging station. The route envisages at least one stop in each of the 6 villages to meet local needs in terms of ensuring a bus stop and walking distance as far as possible. The energy retrofit of the public educational building aims to create smart school infrastructure with nearly zero energy consumption in combination with the charging and use of the electric vehicle, the development of sustainable awareness of citizens, thus bringing significant social, environmental, and economic benefits. Here we see the impacts obtained, which are predicted by this table using the National Building of Energy Performance Software, CANAC. And the annual total primary energy consumption is expected to be reduced up to 16.7% compared to the existing situation. In the next slide, you see here the annual total CO2 emissions, which are expected to be reduced up to 66% compared to the existing situation. In conclusion, we have an upgrade of public educational building to green intelligent building of nearly zero consumption, which will serve as a demonstration project for other public educational buildings of Greece. The proposed improvement of the energy retrofit reduces the primary energy consumption by at least 68.7%. Regarding the rest contribution, PV system of 10 kilowatt is suggested for the energy production of the pilot building and the charging station. Moreover, the replacement of a conventional vehicle of an electric one with an electric one, supported by the REST PV, leads to the total avoidance of CO2 emission at around 16 tons per year. The project aims to increase environmental awareness, since the renovation project is being applied to an educational building, which enhances the demonstrative character, considering that the end users are students being familiarized with innovative energy technologies. And the results, of course, can be utilized by any other area with similar climatic conditions and building stock. Thank you very much for your attention. With me, I have the project engineer supervisor, Mr. Manois Manusakis. If you have any questions, thank you again.